Let's talk about conditional probability. Pause the video, take a few moments, and go through the letters A through G, and then when you're done, press play. Alright, here are your answers to letters A through G. Hopefully you're all familiar with these. So understanding that location and population density is not independent, because when you multiply their probabilities, it's not equal to the location and the population being urban or rural, just using here eastern and urban as examples. Now, before we get into letter H, let's flip over and truly talk about conditional probability. So, conditional probabilities, you have the little divider as a symbol, represents the probability that A will occur given B has occurred. So B, you're given, we're looking at your formula, will always go in the denominator. Whatever the given will always go in the denominator, and with it being the probability of A and B on top. This is just another form of the equation solving for the and. If you were given the conditional probability times the probability of B. So, for example, what's the probability of A given B? So if we know the probability of A and B is 0.25, and the probability of B is 0.4, if we divide those two things, we will get our probability of A given B of 0.625. Take a moment now, try the next example on your own, and then press pause, do the problem, and press play when you're ready to continue. So, suppose the P of A is 0.35, P of B is 0.4, and the probability of A and B is 0.2. So if we do the Venn diagram first, there's an overlap of 0.2. So this is A and this is B. So only A is going to be 0.15. Only B is going to be 0.2. And not A and not B is going to be 0.45. So are A and B mutually exclusive? No, because the probability of A and B is not equal to 0. That's how we know that they are not mutually exclusive. So we can use the addition rule to determine the probability of A or B. Remember, that's the probability of A plus the probability of B minus the probability of A and B. In this case, we're going to have 0.35 plus 0.4 minus 0.2, so that the probability of A or B is going to be equal to 0.55. Now comes our conditional probability. The probability of A given B. So again, that's going to be equal to the probability of A and B divided by the probability of B. So that's going to be 0.2 divided by 0.4, which is simply going to be 0.5. So, in terms of independence, are A and B independent? Where if you multiply the probability of A times the probability of B, in this case, it is not equal to the probability of A and B, because 0.35 times 0.4 is not equal to 0.2. So no, they are not independent. All right. So now, flip over to the next page. Let's look at the next example. All right. So we have 500 individuals were classified into 3 age groups, and they were placed in groups depending upon their blood pressure. So if a person is selected at random from a group, we're going to find the following probabilities. So the probability that a person is in age group 3, there are 150 people in age group 3, 500 total, so that's going to be 150 over 500. Remember, you should not reduce. The probability that the blood pressure is above 90. So the blood pressure is above 90, that total is 170. So that's going to be 170 over 500. The probability that they're in group 1 and the pressure is below 70. So group 1 pressure is below 70 is 20 out of 500. Now the probability that they're in group 1 or the pressure is above 90. So the probability that they're in group 1 plus the probability that the blood pressure is greater than 90 minus the probability that they're in group 1 and the pressure is above 90. That's going to be equal to 250 over 500. Now E gives us our conditional probability. So we want the probability that they're in group 2 given that their pressure is less than 70. So we're going to take the probability of being in group 2 and pressure is less than 70 and divide that by the probability that they are in, that their pressure is below 70, sorry. So the probability that they're in group 2 and their pressure is below 70 is 30. Over 500. And that's divided by the probability that their pressure is less than 70. Which is 70 over 500. Anytime you're dividing a fraction, remember we have to flip and multiply, so this becomes times 500 over 70. But 500s can cancel out, and we're left with 30 over 70 as our answer. Okay? So pause the video for a moment and try letter F on your own. Press play when you're ready to continue. Okay, so if you look at the pressure between 70 and 90 and in group 3, divided by the probability that they're in group 3, gives you the 60 over 500 divided by 150 over 500. So again, multiply by the reciprocal and you'll get 60 over 150. Another way of looking at it, especially if you have the table, the given is that they are in group 3. So there are 150 in group 3. So of that 150, there are 60 that have the blood pressure between 70 and 90, with our answer being 60 out of the 150. So again, once you make the relationship between what's given, only focus on that particular group. All right, let's take a look at the next example. 60% of applicants at a high-tech firm have a college degree. 40% have at least 3 years of experience. And 35% have a college degree. and 3 years of experience in the high-tech industry. So we have the probability of having a degree is being 0.6. Probability of having experience, we'll say, is 0.4. And the probability of having a degree and experience as 0.35. So if we're going to find the probability that the person has a degree or 3 years of experience, again, we can use the additional rule. So the probability of having a degree or experience is equal to the probability of the degree plus the probability of experience minus probability of the degree and experience. So we're going to take our 0.6, add the 0.4, and then subtract the 0.35. So our answer is 0.65. For our next example, we have production process producing widgets. 20% are defective. Each item is inspected before being shipped. The inspector misclassifies an item 10% of the time. So what proportion will be classified as good? So we're going to make a tree diagram. And I'm going to use D for defective and G for good. So 20% are defective, which means 80% or 0.8 are good. So out of those that are good or defective, 90% or 0.9 is classified as defective, and 0.1 is classified as good. Of those that are good, we have the 0.1, it's classified as defective, and the 0.9 is classified as good. Because we're looking at, again, that they're misclassified 10% of the time. So if it's good, it's going to be misclassified as defective 10% of the time. Okay? So the question being asked, what's the proportion that's classified as good? So we need the probability that it's defective and classified as good, and the probability that it's good and classified as good. We're going to add those two things together. So we'll take our 0.2 times our 0.1 and get 0.02, and we'll take our 0.8 and multiply by our 0.9 and get 0.72. So the probability of it being classified as good is going to be 0.74. Okay. Pause the video and try example B and C on your own. Press play when you're ready to continue. Okay, so on B, you have a conditional probability that the widget is good, given that it's classified as good. So we've already found the probability of being classified as good as 0.74. So that's going to be our denominator. And the probability that it's good and classified as good is going to be 0.72. So when we divide those things, we're going to get 0.97, which means 97% of the items shipped are good. Conversely, what percentage of the items shipped are defective? So we need the probability that they're defective given that they're classified as good. So that's going to be the probability that it's defective and classified as good, divided by the probability that it's classified as good. So the probability of being defective and classified as good, we found for the previous example to be 0.02. 0.02 divided by the 0.74, which gives us 0.03 or 3%. Okay? So hopefully this video will help answer some of your questions. If not, look forward to answering them when I see you again. Make sure you complete worksheet 4-6. Check Blackboard for your solutions and have a good break.